Hi, we'll be talking about inverse variations today, and first off we're going to talk about the constant of variation for an inverse variation. Okay, so the constant of variation is this k. Now that number is always going to be constant for a certain type of problem, whether you're using a certain type of spring or a certain type of money amount, that type of thing. Whatever it is, it's going to be the same amount for that certain type of problem. Now if you switch problems, it's going to change, so k is going to change depending on what it is. Okay, but usually what you're going to do with it first is you're going to find it by multiplying what you deem to be the variable y and x together, the initial conditions. And then what you're going to do is you're going to plug it back in and then solve for a new y or x value depending on how it works, and it's just going to help you be able to work with that. Okay. Alright, so if we set it up, this is really kind of easy. Okay, real world application is if I take a fulcrum, which is just basically a fancy physics term for a balancing point, and I put a really heavy elephant on one end, about 1,000 pounds. Okay. And then I put, let's say Mr. Devaney on the other end, who is about 200 pounds. Okay? And let's say that the elephant is about 7 feet from the fulcrum in this problem. How far does Mr. Devaney have to be? Okay? Alright, so what we're going to do first is we're going to find the actual constant of variation. Okay. All right. So the constant of variation is going to be 1,000 times 7. And I'm sorry, we should probably define these terms. This will be my well. Let me see. It doesn't matter. You can actually switch them up. Let's just define this as, well, let's do y and x since I already have that as x. Okay, so, alright, there we go. Okay, so k is actually going to be 7,000. Okay, now when I plug it into the problem, I'm going to plug it back in and I'm going to get y equals 7,000 divided by x. Okay, now if you notice, I know that it's going to be 200. Okay, so my new y is 200, so if I plug in 200 and equals 7,000 divided by x, okay, what I'm going to do is I'm going to multiply both sides by x just to solve it. Okay, and so I get 200x equals 7,000. Okay, and then I'm going to divide both sides by 200. Alright. Okay. And x is going to be about 35 feet. Okay, so technically I need to be about 35 feet away from the fulcrum in order to balance a 1,000-pound elephant. Okay. Now, what it's going to say is when you set up this fulcrum problem, it's going to say fulcrums they're going to say fulcrums have an inverse variation relationship. This is going to be your key to know that we are dealing with an inverse variation and we can actually work with this, okay? Alright, so number one step, whenever you see inverse variation, write out this two sets of problems. Step number 2 is find the constant of variation, and step number 3 is to actually calculate it. Okay, and then you can actually find any answer this way possible, as long as it's an inverse variation. The cool thing is that this all leads from the fact of what happens if I have an x in the denominator? How do I solve for that? And that's where this whole chapter came from. Okay, so inverse variation, set them up like this. Write out these two equations first, then find the constant of variation, and then actually solve for the other value. Now, if I change the y and the x, it would still be the same. I would actually still get the same type of answer. Okay? All right. that is it for working with this inverse variation problem. I'll talk to you later. Bye.